Explain why v squared is a minimum when, and then they give you an angle for theta, a value for theta. Okay. Now, can we just pause and think about, before we launch into the algebra, what this has to do with the rest of the question and what it physically means, right? Have a look in the same page back at part 2. Back at part 2. The idea is that theta, this is the angle you're actually shooting at, right? Clearly it has boundaries, right? I mean, if you actually want to get the ball in, it has boundaries. You can't throw theta below alpha. Why not? Because then it doesn't matter how hard you throw that ball, right? You can throw it with infinite velocity and it will still go underneath the hoop. So, no point, okay? In the same way, you can't throw it any bigger than pi on 2. Why not? Because then you'd be throwing it away from the hoop. Okay, so we've got values that are restricted there. But we've just noticed that for either one of those boundaries, right, alpha or pi on 2, if you used either of those, then you'd have to throw with infinite velocity, right? So there's some spot in between where we get this sweet spot, and that's what they're searching for, right? When v squared is a minimum. Okay. Look at all the pieces that you've got together, okay? You're looking for v squared to be a minimum, okay? Now look at everything you've established. Look at like the page and a half of working you've got, okay? You want v squared to be a minimum, and remember, v squared is 5d on. Now, I have a name for this denominator now, and I know a lot about this thing. It's f of theta. Now, we want v squared to be a minimum, which means f of theta ought to be a maximum. Okay, file that away. File that away. Now we're ready to solve this question. Okay. Think about it. Think about it. It's the same logic we applied over here, right? You want the whole thing to be small. That means you need the denominator to be big, or vice versa, if that was what you wanted. Okay. So I'm going to take their value, right? This is part 5, the last one. When theta is this value that they're supplying, when this is the case, I know something about alpha tan to theta, right? Just like this is how I got to here, right? This also means this. Does that make sense? Okay. So if that's the case, tan to theta? Yeah. Tan to theta tan alpha is equal to -1. But if that's the case, that also implies something else back about f of theta, or more specifically, f dash, right? Where did this come from? Yeah, good. It came from this guy, right? You see how we're climbing back up the logic that we went all of this, applied all this effort to get through? So if that's the case, therefore f dash theta is 0, so I have a stationary point. But remember what I was trying to establish. I was trying to say something particular about f theta. I want it to be a maximum, so therefore it's not enough to know it's a stationary point. I have to know what kind of stationary point it is. Okay, so tell me, we've got 2 methods for determining nature. Which one would you like me to use? Table values? Yes. No. Really?
Second derivative is opinion.
Where even are we?
Hold on, guys. Hold on. Slow down. Yeah. Have a look at this guy. Right? Have a look. Is this hard to differentiate?
No.
Not at all. You've got cosines and sines out. Admittedly, some students look at it and they're like, oh no, it looks terrible, because they look at this guy. Which doesn't matter. Why not? It's a constant. Okay, I'm going to differentiate again. Okay, use the second derivative. Now, of course, if you went by the table of values, that's fine. Okay, you're going to encounter some problems whichever way you go. I'm going to evaluate them, but I'm just going to say from the outset, I think the problems you have to deal with end up easier with the second derivative than with the first derivative, aside from even the differentiating. So let's go ahead and let's work out what f double dash is equal to. Cos 2 theta?
-2 sin 2 theta.
Thank you. Second part?
4 theta.
4 theta? Go home, Raph. You're drunk. Okay. What happens here? I'm going to get the tan alpha out the front.
2 cos 2 theta.
Thank you. Yeah, okay. Good job. Alright. He's with us now. Okay, now, I've got my second derivative, and I've got a value to test the second derivative for, right? So I'm going to say, therefore, f double dash of that guy is going to be equal to, okay, now note, I have a 2 theta, 2 theta. So I need to double this thing, right? That looks to me like I'm going to get sine of alpha plus pi on 2. And there's a 2 there. Cos of alpha plus pi on 2.
I wrote this line and then I crossed it out because I thought it was too complicated.
Okay, now like I said, maybe at this point you're like, oh no, I regret everything. Maybe I should go for my table values, okay? I'm going to stay with this. Let me try and justify it for you, okay? Suppose you went for your table of values. Suppose you went for your table of values. I'm not even going to do the whole thing, but what you need is to say, I've got my value of theta. I've got my f dash, right? And then, for this value, I know it's going to be 0. And then for this value and this value, I've got to find something here. Now, I've labeled the fact that you can't just say it's positive, right? You actually need a value there, okay? Problem, I don't know. I can't evaluate that. I don't know what alpha is, right? I can't punch this into my calculator, okay? So I'm going to have to reason through what alpha is, and I have restrictions on alpha as well, to be able to say, not only, what's this supposed to be, by the way? F, what am I looking for? I want this to be a maximum, right? So I want this to be positive, I want this to be negative. I'm going to have to say that about both of those things, okay? Here, I just have to deal with one value, okay? I just have to deal with one. So I think this is going to be a lot easier to work with, okay? So I am going to take out, I can take out this factor 2. The 2 doesn't matter to me. What matters is the sign, because I'm looking for concavity here. Okay? Now the sign of this thing, we're used to something nice and numerical and easy, but this is not nice and it's not numerical either, okay? So there are 3 parts I've got to deal with. 1, 2, 3. And they all change sign dependent on what alpha is, okay? Now think for a moment, what am I wanting? I want this to be a max, which means what about all the signs of these things?
The first one's the negative minus.
If I want this to be a max, let's think about this.
To be less.
This thing, just think about the logic for a second. This thing I want to be a minimum. That means this thing I want to be a maximum. That means this thing I want to be concave down. So I want this to be negative. Okay, that's what I'm after, right?
Yes.
So think about it this way. The easiest way would be, think about each of these within the domain that you know for alpha. Okay, what's the domain you know for alpha?
0 to pi on 3.
Okay, you ready? I'm going to draw 3 graphs for you. I'd love you to follow with me. They don't need to be beautiful, but they need to be enough to argue about these things. Okay, so I'm going to draw graph 1, graph 2, graph 3, because there are 3 pieces. Okay, these just have to be good enough for me to argue from. Okay, sine of alpha plus pi on 2. I know what sine looks like. What happens when I have whatever plus pi on 2? I've shifted to the left, okay? So sine's normally like this, right? Oops, sorry, there, right? So I'm going to have to move to the left by pi on 2. That's cos, right? Okay, from 0 to pi on... Where's pi on 2? On here.
0.
It's there, right? That's pi on 2. Okay? So therefore, in the domain I'm interested here, this guy is positive. Thumbs up. Okay, so I'm going to write that down. For this domain, sine of alpha plus pi on 2 is positive. That's really good, because that means I don't need to worry about this anymore. If that's positive, minus 2 times that is negative, so that, no problems for me. Okay, let's have a look at these guys. Tan alpha. What's tan alpha look like? Okay, I'm just worried about this first quadrant, right? 0 to pi on 2. And that's very, very positive, right? So therefore, I can say, cool, tan alpha is also going to be positive. Now that means I need for this to be negative, right? Because I've got positive, positive, this is baby negative, otherwise I'm in some trouble, okay? So I'm going to graph this thing. I know what cos looks like, but then I need to shift it pi on 2 to the left, right? So it's going to look like
Minus sine.
minus sine, isn't it? Right? And look, where's pi on 2? It's here. Okay, does that make sense? So within this domain that I'm interested in, breathe a sigh of relief, cos of alpha plus pi on 2 must be negative. Does that make sense? So by reasoning here, all of my pieces are negative, therefore f double dash at that particular value is going to be below 0, right? i.e. concave down, maximum turning point. Okay. Well done. Take a breath. You did all the hard parts. You haven't quite answered the question though. What do I need to do to tie this all up in a nice bow? Okay, so if f theta is a maximum, right? Therefore, 5d on f theta is a minimum. Does that make sense? I guess the you don't need this language, but what's going on? V squared and f of theta are inversely proportional to each other. One gets bigger, the other one gets smaller. Okay, so therefore v squared is minimized, and if you minimize the square of something, you've minimized the thing itself, right?
But they asked for V. They asked for V squared, sorry.
Oh, did they? So I don't even worry about that. There you go. So an extra line. Okay.